Hello, welcome back to Saturday's series for our second workshop on glaciers. So today we're going to be talking about glaciers, which are perhaps surprisingly a really expansive part of our planet. They cover a lot of area on Earth, and they also have some important contributions to our climate system and to sea level as well. This is also my favorite part of the cryosphere, which is really a term just for everything frozen on Earth. So that can be snow, that could be ice on lakes, and it also includes glaciers. And they're glaciers' larger sibling, ice sheets, which we will talk about in just a few minutes. To reinforce some of the lessons that you will learn today, we will be doing two crafts. So you'll be doing a watercolor postcard that you'll send to a glacier studying scientist. And we have provided the stamps and the address labels for you. And then you'll also be doing a snow-inspired hanging sculpture or mobile that you can hang from your ceiling. And Kate will be talking about the craft projects after we go through some important parts of glaciers and what they are. So let's get started with part one. So first we're going to learn about snow and glaciers. Snow is the building block of glaciers. So glaciers are made of snow. What is snow? We've seen a lot of snow here in Charlottesville, it seems like recently. Looking out my window now, there's snow or sleet. But snow is frozen, solid precipitation. The interesting thing about snow is it has a special and unique crystal shape. If you're not familiar with crystals, feel free to pause the video and check them out. So snow crystals are pretty small. If you are familiar with measurements of length, they are 2 millimeters or in length or diameter, depending on the shape. Also feel free to check out those terms that are bolded in the lesson too regarding measurements of length. And in image one, you'll see a red line that shows the length of 2 millimeters relative to those pictures of snow crystals that are shown. Okay, so here it might be fun to think about how snow is different than like sleet. Sleet is freezing rain or artificial snow, which is used to supplement hill slopes in places where skiing is done in the winter. And this is artificial snow is heavily used in or at Wintergreen, just about 33 miles from Charlottesville, where people ski. Actually, I haven't been yet, probably should at some point. So there are some big differences between sleet and artificial snow, and feel free to pause me and to think about how they could be different. In the background, you hear my dog snoring. Sorry about that. At the end of my recording, I'll show you my dogs if they're still in the room. Okay, so snow falls in a lot of places, right? Like it falls here in Charlottesville, but also just in the winter, snow falls in many, many places, including mountains, including the Arctic and the Antarctic. Remember, we talked about those in the Aurora lesson. So the Arctic being the region that surrounds the North Pole and the Antarctic being the region that surrounds the South Pole. And then in non-tropical places like here in Virginia. But a really important question thinking about glaciers is, where does snow stick around in the summer? And by stick around, I mean, where does winter snow not melt in the summer? And so places that stay colder than your refrigerator in the summer can either gain new snowfall, so new precipitation that's frozen and has that special crystal shape, or keep winter snow from melting. And in image 2, you can see a map that shows the northern hemisphere, remember the top half of the planet. You can see where snow falls in the winter and also in the summer. And so in these cold places where snow sticks around for hundreds to thousands of years, this snow can pile up to create glaciers. And have a look at image 3, which is showing a glacier that is in a mountain valley in the Swiss Alps. And so glaciers are these huge blocks of ice that form from squished snow. And glaciers are so big and so heavy that they actually move across the land by the forces of gravity. I should have bolded that word too. Definitely check that out if you're not familiar with that word gravity. It is very important. Some glaciers, because they move, they drain ice can drain ice into the ocean, similar to like how a river can drain water into the ocean. So these are really they can be like rivers of ice that are flowing across the landscape. There are a few videos that you can watch now. So there's a video of glaciers in Alaska, and then a video of glaciers in Antarctica and Greenland. For Antarctica and Greenland, the glaciers are so big that they're actually called ice sheets because they cover nearly the entire continent of Antarctica and of Greenland. So pause me now, check out those videos, which will be good inspiration for your watercolor postcard. And just resume me when you are done. Okay, so how does this snow get squished? So the overlying weight of snow, so you have a snow layer and then you have more snow on top. So the weight of this snow that's on top of this layer is actually going to cause that layer to squish. And over time, those snow crystals get compressed and sort of bonded together. They also change shape to turn into ice that no longer has that crystal structure. And so this glacier ice can be hundreds to thousands of meters thick. And so that's in some cases, that's taller than buildings built by humans. And glaciers can cover land areas that are larger than any city on Earth. So these are quite massive blocks of ice that are sitting on land. Now we can go to part 2 and think about where glaciers are, where they exist, and why they matter. So looking at this image, image 3, right, like this might seem like a foreign landscape, being here in Virginia where we don't have glaciers, but there are nearly 200,000 glaciers on Earth and 2 large ice sheets in Antarctica and Greenland. Together, they cover 8% of Earth's surface. And in image 5, you can see the distribution of glaciers and ice sheets. So there are glaciers in the Arctic and the Antarctic, but also in tall mountains worldwide, like the Rocky Mountains, the Himalaya, Mount Kilimanjaro, and also in New Zealand. That's just an example of places where glaciers exist, but you can check out this map and see the full distribution of glaciers. You could also pause me now to look at some of these places on a map and type in the location name plus glacier, so you can see some examples of glaciers in these places that I've mentioned. The majority of water comes from the atmosphere, right? So the majority of the majority of water in the atmosphere comes from the oceans, right? So that's important to think about for all of the snow that falls and builds up over time to form glaciers. So because this moisture is coming from largely coming from the ocean that eventually gets trapped into glacier ice, the growth of glaciers and ice sheets actually causes sea level to fall. So if you're in a coastal location, it might be, easy to think about sea level rise and sea level fall, but if you're not familiar with the coast or like being at the beach, right? So a sea level fall would be that the coastline extends farther into the ocean and that the water level drops. And so when glaciers shrink, when they get smaller and melt, they actually cause sea level to rise. And so this is really an important bit of information about glaciers, is that they are a huge reservoir, so to speak, of sea level rise moving into the future in a largely warming climate. And so the reason that there are some glaciers that are not shrinking today, and the reason that these glaciers aren't shrinking is because that they are getting more snowfall. And this is also linked to climate change, because the warmer the air is, the more water air can hold. This is something that you're welcome to pause me and to check out on your own now if you want. So this warm air holds more water, and it's going to be cold somewhere, say at like the top of a mountain. And that water will fall out of the atmosphere as snow in these cold places and cause some glaciers to actually grow in this period of climate change. But those growths, those local growths for some glaciers don't overcome all of the losses of glacial ice due to melting in this period of climate change. Another really important consideration for glaciers is that they're important in sending some solar energy or heat back to space. So we know that the sun sends a lot of stuff to our atmosphere. We learned about that with aurora. Aurora is a visual sign of that stuff coming from the sun. So the sun sends energy or heat into our atmosphere as well. And that heat is absorbed by the land. In places where there is ice cover, however, places that are super reflective like ice and snow, most of that sun sent energy bounces right off the land surface and goes back into space. And so this is one way that we can sort of mitigate potential warming by having this reflective cover on the land surface. But now we're losing a lot of that ice and snow as temperatures increase. And so that leaves more soil and rock and plants that are covering Earth's surface. And because rock, soil, and plants are generally less reflective than ice and snow, there's more heat that's being trapped in the land. You can think of sort of like land being a sponge for that heat. And heating of the land also heats the atmosphere. So not only are glaciers important for thinking about sea level, but also for thinking about this sort of cycle of warming. You lose ice and snow due to climate warming, but then also you get even more warming because there is less ice and snow to send energy, heat back to space. So who studies glaciers? You may have heard of a biologist or like a journalist. Well, a glaciologist studies glaciers. People who work for places like NASA and for universities study glaciers all over Earth, and there are even people who study glaciers on Mars. I myself am a glaciologist, and I study how and why glaciers change. So glaciologists can study glaciers by either going to glaciers that exist today, by using measurements that are taken by airplanes and satellites, or studying the land and the oceans that are altered by glaciers. An interesting question to think about, especially for your postcard, is if you were to become a glaciologist, what would you want to do? Would you want to take measurements on the ice yourself? Would you like to fly over them and take measurements? Would you like to study the oceans around them, or use data that's collected from satellites? And this is something that if you want, you can put on your, you know, like if I were a glaciologist on your postcard to send to your glacier studying pen pal. But there are also, besides glaciologists, there are also engineers and biologists and oceanographers and social scientists and pilots and computer scientists and people who study math who also think about glaciers or work in places that are near glaciers. So there's a whole sort of range of occupations that think about and study glaciers. Okay, so we're done with the big lesson part for this workshop, and now Kate will take over and walk us through the postcard and the hanging sculpture or mobile, and then talk about some of the closing remarks and some references to additional resources for learning about glaciers. Have fun.